Hey kids, Smath here. Got a couple of videos coming up in this series that are going to deal with solids, crystalline solids. And I want to go through these. Let me share a screen with you really quick. Okay, so there we go. This first one is going to be called the Bragg equation. Now, before I go into that, let's back it up and let's talk solids. Solids are composed of a crystal lattice. That crystal lattice is a regular pattern. That's the important part here. It's a regular pattern. If it doesn't have a regular pattern, it doesn't have a crystal lattice. If it doesn't have a crystal lattice, it's not a real solid. It's going to be considered an amorphous solid. So the only solids we're discussing are crystalline solids that have this crystal lattice. Crystal lattices can be broken down into unit cells. Unit cells are the simplest repeating form of this lattice. Simplest form of lattice. So the only unit cells that we're going to concern ourselves with in this class are going to be simple cubic unit cells. So we're going to deal with cubics. Well, as the name implies, if it's a cubic unit cell, it's going to be a cube whose dimensions are all going to be equal, and those dimensions are going to be equal to L, which is the length. You may see that sometimes in some books that may be considered A as well. I'm not sure why they use A as that, but L is going to be the length, and so V is going to be L cubed. So what this first equation, this first type of calculation helps us with is called the Bragg equation. The Bragg equation uses X-ray crystallography to measure L. So this is how they get L. The equation itself is quite simple. It is n lambda equals 2d sine theta. And in this one, n is going to be considered the order of the diffraction. That's the number of layers that they're looking at, which will usually be equal to 1. Lambda is going to be the wavelength that's used. Lambda is lambda. D is going to be that length, that L that we're looking for. It's going to be that distance between layers. Okay, and theta is going to be the angle of deflection. Now, there's one other thing that comes up in this, and it's measuring this distance. And quite often, they're going to give you a measurement in angstroms. This funny A with a circle on top of it, that's called an angstrom. And 1 angstrom, capital A with a circle, is going to be 1 times 10 to the negative 10th meters. That's just kind of a nice thing to have in your arsenal. So let's make that red. That's kind of important. Okay, so let's do an example problem. It says an X-ray with a wavelength of 7.04 times 10 to the negative 11th meters gives a first order diffraction that tells me n equals 1 with an angle with theta equal to 15 degrees. Calc the lattice spacings. The fancy way of saying calculate D, which we said D is equal to L, so don't worry about that. Okay, so set it on up. N lambda equals 2D sine theta. The rest of this is just plug and chug. We've already got things in meters. If you've got a wavelength in meters, then your D is going to be in meters. If you've got a wavelength in meters and you need D in angstroms, you got to do some conversions, get it to the right units here. But we already said N is equal to 1. That really doesn't have a unit. Lambda 704, 10 to the negative 11th meters equals 2D sine 15 degrees. This is a sine function. Remember to keep your calculator in degrees. This is one of the very few times that we're going to need to make sure our calculators are in degrees and not radians. I'm not sure why you guys would ever be in radians anyway. But if I munch them, crunch them, I get a D here of 1.36 times 10 to the negative 10th meters. That's going to be equal to the length of my cubic unit cell. L equals that. And from that, we can springboard into calculating the volume, getting the density, and doing some unit cell calcs. And those are coming up in future problems. But this is the Bragg equation that helps us to calculate how we actually can solve to find that volume or that unit L. Okay? I'm Smath. That's how you do Bragg equations. And I sure hope that this video helped.